No, thank you so much for the kind introduction, Lynn. And thank you for all of you coming here today. It's really good to see a room full of people that are interested to hear about NeuroLibre. This presentation is a website. You can scan the QR code and see the components if it doesn't come through this platform somehow. So I'm going to talk about 7 years of developing NeuroLibre and see if we came close to parting ways with PDFs and build a literature that is integrated. So I came to Montreal in 2017 to do my PhD with Nicola, and one of my first two tasks was to deploy an open source software to cloud. I had no idea how to do that at that time. And then the second one was to make a cardiac T1 mapping article reproducible and incorporating interactive figures. At that time, I didn't know that this was actually the #1 driving force of the development of NeuroLibre. And trying to figure out how to achieve this, I discovered Binder through this blog post that was published on eLife by Jeremy Freeman. And at that time, Binder was a project in this research lab, HHMI Genelia. And Binder, they said this magical tool, you just give a few configuration files to your GitHub repository, and then it opens a tab in a web browser and you can execute your code. That sounded awesome, and I wanted to give it a try. And I started building different repositories. And here in that blog post, they actually noted, currently, we don't support data as an external resource. For now, you need to put it on your GitHub repository. And they clearly said that we want to work on new ways to integrate static papers and interactive notebooks. Even with Binder, these remain separate and very different kinds of documentation. And since that day, we've been working really hard on bringing all these pieces together. And then a week later, I was chatting with Chris Holdgraf on Gitter. Chris is here with us today, and I was not able to find one of my notebooks or having some problems. And then on September 8th, which is my birthday, I was talking to Chris again. And this time I was actually able to run an Octave container on Binder Hub. And I guess it was one of the earliest examples of running MATLAB code on a platform that can be shared with a lot of people. And with that, I was able to make that paper reproducible. I got interactive figures. And then it was published on bioRxiv as a preprint. Let's talk about cardiac T1 mapping was the title, and it's still a preprint on that platform. And just because it was not published on NeuroLibre, when I tried to reproduce that article today, some of the packages were outdated and I wasn't able to run. And that's an important thing to keep in mind because I had to rebuild everything. So Binder is an indispensable part of NeuroLibre workflow. And fast forward to 2024, now we have two deployments of it. First is a public one. You can just go to this Binder preview service. You can put your repository. This is a bit customized template, and you see there's validate repository content. If you click that, it's going to go through all the files on your repo and see whether you structure your repository in the way that we expect. And then you can also start building your reproducible runtime environment for that. And then the second Binder Hub deployment is reserved for published articles so that when people want to reproduce the article, it can provide fast and reliable service. And this separation between preview and preprint has been really fundamental to all other tools we built around the entire publication workflow of NeuroLibre. So back to 2018, when NeuroLibre has become officially a project under the umbrella of Canadian Open Neuroscience Platform. So this was the initial development team that we had. So we had the idea of stitching together a publication workflow for living publications. It sounded good on the idea level, but when it comes to implementation, we didn't really know how. At that time, I recommended, hey, there's this cool journal, JOSS, they have an editorial blog, maybe we use it. But that idea didn't fly at that time because we said like, no, they're just doing probably PDFs. We want to do more. So we had to come up with our own workflow. So I tried to come up with something that started with a Google form submission that go to the Google server list, triggered then another app to go to the GitHub Actions for repositories, push things, and then eventually push a card on NeuroLibre.com. And that was kind of the workflow, and it was also detached from our Binder Hub deployment, which was at the time either Kinder Hub, because it was disappearing from the view half of the time, or it was a Kinder Hub, because you were really surprised when it worked. So ironically, all this workflow we put together to avoid publishing PDFs ended up being used for publishing PDFs for brain hack proceedings, and also kind of the set up the infrastructure of MR Hub, another reproducible publication platform for an MRI society. Then on November 14, 2018, we received this email from Pierre Lun. It says, from notebooks to book. And that's a repository on Create Graphs again, GitHub. And it's a nice template to build book from notebooks. It's building a web page from a collection of Markdown files and Jupyter notebooks. And Jupyter Book was definitely the second driving force of the development of NeuroLibre. And it was a solution that encouraged other solutions for us. So seeing the target, seeing the final product inspired us implementing ways to get there. And some of them were repo to data. It's a Python library that downloads data and links it to the interactive session of your notebook. And NeuroLibre.org was born around that time again. It's a deployment of Open Journal's editorial management and paper submission platform. And we have RoboNeuro, that's an editorial bot that is bridging NeuroLibre.org with GitHub. And Pierre already showed Jupyter books are interactive documents. There are web pages. You can embed interactive figures, source figures. This is the end product. It's the target story. With this structure we came up with, you're going to have a folder for binary dependencies. You have a content folder and another folder for putting your metadata about who are the authors.
Attention, attention, code move, premier S, chambre, 15, 17. Attention, attention, code move, premier S, chambre, 15, 17.
So we knew the source today. There were a lot of missing links, and it took us a while to figure out what we need to put in between. And come 2021, it was a server that is owned by NeuroLibre. What is that?
Exit, because it's going to stay.
There you go. So we started developing our own server, and it had different interfaces to RoboNeuro, to Zenodo, GitHub, and both of the Binder Hub deployments, to NeuroLibre.org, and to our private Docker registry, where we keep the Docker images for each one of the published preprints. And we also had a servers to serve these static HTML pages, which were Jupyter books. And we had a different flavor of the same server to cater to different needs during the technical review. And right now it's deployed on OpenStack. We pretty much ate up all our resources to orchestrate these different servers. There are tens of different subdomains, but they're all living under either CONP.cloud or NeuroLibre.org. And it took me shuffling all these different tools to be able to get to that point. I'm not going to bother you with any of the details because it's not chronically fun. It can get really annoying, especially that Kubernetes part. But I wanted you to have fun for 1 minute with all these tools. So I came up with a music video. I hope you're going to be able to hear it. And you can't hear it.
There's a way to share all that.
You need to plug in the audio. It's the same kind of isomètre de son. Je pense qu'il suffit juste de plugger ça dans ça, non?
Should I try? Yeah, okay, good. I'll go back. I guess we should say continue recording to this, and it's gone. Can I turn up the volume something? Yeah. Okay, thank you. There we go. So that was an inside joke that kept coming up in bunch of different meetings. And it was a really important concern. What happens if one of the core developers got hit by a bus? And I'm pretty confident to say that today we have a pretty stable infrastructure that can be teared down and redeployed over and over again. And now we have this powerful living preprint platform on which launched Binder Hub, and it's going to give you your repository data, Jupyter Book, and container archive, and there it's going to link them all together to create a powerful literature for you. And as Pierre said earlier, we published 10 living preprints and archived more than 100 gigabytes of reproducibility assets for them. And then you may ask, what about supplementary material? And I think supplementary materials are supplementary because publishing platforms don't know any better. So you don't have to provide a supplementary material. Instead of providing a bunch of pages of Excel spreadsheets in landscape format, you can create interactive figures or even dashboards. We have a platform deployed on NeuroLibre to host dashboards. And this is one example. It's a depressing dashboard for early career researchers because it only has the top 2% of the researchers in the world ranking them. You can go play with it. It's we have a QR code there, and it's indexing 1.2 gigabytes of Excel spreadsheets in Elasticsearch so that it's really fast to capture and interact with data that you wouldn't be able to load to your Excel otherwise. We have another one also developed in Dash by Plotly. It's for a reproducibility challenge. It's embedded in a NeuroLibre preprint. We deployed another dashboard, which was developed in RShiny, and it's also embedded in a NeuroLibre preprint. These dashboards were probably hundreds of figures that you cannot capture in a static publication format. We cover simple tasks too, such as indexing ourselves on Google Scholar or making sure that your preprint shows up on ResearchGate the next day. You can receive citations. This is an early publication with 30 citations, and you can also give citations when you're publishing your paper. And speaking of these simple tools, it's actually costing us billions of dollars every year. It's just for indexing, searching, and counting citations. What is promised by this big tools is somehow delivering insights, discovering insights, finding actionable insights in healthcare and big data. What is delivered? And ChatGPT summary in the abstract section of a paper, which is a case report about hepatic artery injury of a 4-month-old female patient. And as if it's not depressing enough, you need to pay $550 to make a full of this. When they are not depressing, they can be really funny. Here, this is one of the journals trying to be innovative by fixing the abbreviations of flip angle, FA. So it wasn't supposed to be curly brackets or square brackets. It's supposed to be parentheses. While they were writing that code, there was a typo. Instead of flip angle, it was flip angels. And if you go on Google Scholar, you will find a lot of flip angels of MRI. So that's innovation coming from big publishers. And citations in the bibliographic literature are credit only, which is another problem, right? You give reference to someone et al. 2020. I found this article. This is a PDF. This is my DOI. But what happens when we take away the text? It's just a semantic layer of links to each other, right? They are not going to point to anything. And what remains of a paper when you remove the text, and I guess the previous example shows that what it means to remove the text from a publication. We need to think about this. Can we have a better literature? Yes, we can, which is the driving force number 3 of NeuroLibre. You're already looking in the background of the, I guess, maybe future of publishing. It's a structured data. This is an entire article that can be accessed in ways that you cannot access with PDFs. I'll show some examples. So we have some notebooks, which is translated to the structured content, and then you can render it whichever way you want. It can be a website, it can be PDF, it can be XML JAX, whatever you want. And I'm happy to announce that NeuroLibre now introduces support for MIST. So you can start publishing your preprints using MIST. And let me show you some of these examples from the team server. For example, here, we have a MIST article, search from article.neurolibre.org. And I can just change this article to book to render it differently using a different interface. So this is the beauty of sharing, publishing an article using a dynamic website. But it's just, it sounds like a convenience, right? You can already convert these things between the two. What is the added value? Well, we can build an integrative literature where citations are import statements. So say you import a paper by putting the DOI and you get the narrative code and the figures. I'm talking about the content itself. You import another article with a DOI and get all those resources. Then you realize that figure 1 from the first one is an interactive and you fetch the data from them. And the second one, you fetch the data, you combine them together. And that's how you can deliver insight using the existing literature. You can build on top of someone else's work. If it sounds like science fiction, it's actually not. I came up with a paper section. I put 5 fake publications on NeuroLibre using MIST, and it's about a fake data set, again, looking at the different cognitive scores and brain metrics in 400 aliens. You can go and visit each one of these articles, but I'm just going to open the article, which is a MIST page that makes these papers talk to each other and actually import them into a study. How do we do that? We list 5 DOIs, and then we run the command, NeuroLibre, import these papers. And I'll start running this while I'm talking over. It's connecting this MIST article to a Binder Hub instance, and it's going to attach that instance to this, and it will reproduce all the outputs from this article. So now, as it's running, as you can see, it was able to fetch output data. We are already connected to the session, and we can rerun this. If I manage to click this somehow, yeah, I did. There we go. We just imported 5 articles. And then we can peek into this paper programmatically. Show me the authors, show me the titles, show me the affiliations. It's all going to show up. And you can actually, in MIST, cross-embed different articles into each other. So for example, here, when I hover figure 1, it's going to render a figure from another article. So when you refer to an article in your paper, it's going to immediately show up in that place. That article can be an interactive figure, and you can even interact with that in this panel that opens. And of course, it's also possible to use the same markdown syntax to embed it in your MIST article. But what I want to do is a bit different. So I developed a tiny Python package called NeuroLibre Crosslinks, and I wanted to actually import those papers and fetch data from their interactive figures. So all the interface for that tool is there, and this is the first article, first figure from a NeuroLibre article, an article from the second, and from the third one. Individually, they don't say much, but there's a way to capture all that data and put it all together to see the message sent by aliens linearity index. So this figure is created by importing 5 different papers, and each DOI can be seen here. Of course, we can take this analysis further. We can actually capture all the scatter plots from this different papers to run a meta-analysis that we wouldn't be able to otherwise, because each one of the papers published their analysis using completely different formulas. So there we go. We have a correlation matrix. Then we can run a PCA analysis, show other scatter plots, and even see if the results would be different if we use different matrix by creating another interactive figure for this. Nicola is going to talk about this more. So that's my demo of the papers talking to each other. And I'm really happy that I was able to show this today. So what is the driving force number force of NeuroLibre? It's you. It's you going to neurolibre.org, putting your ORCID affiliations, log in, and submitting a preprint. And I try to make it pretty straightforward. You just start with a repository template. It's on GitHub. You can create it easily and then edit your executable and narrative content. If you have some data dependencies, you can open an issue on NeuroLibre info repository with one of the issue templates you will find. You can define your runtime dependencies using reproducible executable environment specifications, which using Binder Hub. You can preview your MIST for Jupyter book build on robo.neurolibre.org, which is another web application we provide for that. And you can finally submit your paper for technical screening. And on the Binder preview page, we have a summary of these different steps. Or if you want a more comprehensive summary as to how to submit a NeuroLibre preprint, you can visit our documentation. And if you're on the fence about how to publish your next preprint, my recommendation would be to choosing the mystical way forward. And I hope that NeuroLibre has a bright future ahead with all these powerful tools. With that, I'd like to thank all the sponsors and again for all the visitors that came here today, even from Japan. It's an honor and thank you so much.